Okay, so the last time we were here, we were introduced to organic chemistry, and more specifically, we um, talked about different types of hydrocarbons. Of course, just to remind you, hydrocarbons are basically organic compounds which contain carbon and hydrogen only. We also defined organic chemistry as, the discipline which studies, which deals with the study of organic compounds, which, as I said before, are compounds containing carbons. And I gave you some exceptions of compounds that contain carbons that are not considered to be organic compounds. So if I remember correctly, I said compounds containing the carbonate ion, the cyanide ion, carbon disulfide, bicarbonate, and some others, which I can't recall right now. All right. So that's what we started off with. And I think the last time I talked about the series of alkanes, right? Starting from the simplest one, which is methane, then ethane, then propane, and then you have the others. And we went as far as decane, and that's where I've decided to stop at this level. And let me just say that for those of you who have to do organic chemistry, you're pretty much getting a heads up now as to what you'll be learning in the preliminary parts of that course, all right? Such as naming alkanes and so on. Of course, I won't go into any great depth in terms of other topics, because that's what you'll be encountering when you get to that stage. Okay, so okay, so hold on. I don't think I covered this particular slide, so let me just do this quickly. Basically what we're saying here is that alkanes, all compounds that are alkanes share similar properties. They're essentially non-polar, which means that they're all insoluble in water. They're mostly unreactive towards ionic compounds, as well as acid bases and oxidizing agents. In fact, the only reactions that alkanes will undergo are reactions with oxygen, which is true for all organic compounds. When you burn them in air, you're going to get carbon dioxide and water, and halogens. And this is a reaction which occurs by a mechanism which is known as a free radical mechanism, which I won't get into right now. That's for you guys who have to do organic chemistry. So one example of this reaction is a reaction between methane and chlorine. And what will happen is basically what we would call a double displacement reaction, where one of the chlorine atoms will replace one of the hydrogens, and you end up with this compound. And then the hydrogen from here will end up with the other chlorine atom, and you end up with HCl, all right? So that's what happens in the case of methane, and a similar reaction will occur with other halogens as well. And you can have further reactions where all the hydrogens eventually will end up being replaced by chlorine, but I won't go into that. Again, that's for you guys who have to do organic chemistry, all right? Okay, so what we're gonna look at now, if I can get this working, is how do we name organic compounds? And I don't know if I told you, I'm quite sure I told you guys, if you have had me in intro or general chemistry 1, that there's an organization known as the International Union of Pure and Applied Chemists. And these guys, there's a division within that organization whose sole responsibility is to come up with rules for naming compounds, right? I don't remember how often they meet, but I think they meet something like once every 2 years or 3 years or something like that. And that's all they do. They sit down to come up with rules. And the reason why that's important, even though I can imagine it's a very tedious and boring exercise, but the reason why that's important is because every year new compounds are being made, and very often the new compounds being made will not be able to name those compounds based on the existing rules. So basically, these guys have to meet ever so often in order to come up with new rules or modification of old rules in order to accommodate those substances. So they perform a very important role, right? Now, as far as organic compounds are concerned, separate rules were developed in order to name these compounds, right? So basically, according to the IUPAC system, there are typically 4 parts in the name of an organic molecule. You have the parent part, then you have the prefix part, the locand part, and the suffix part, right? So down below, they describe basically what each of these parts are all about. So here it says that the parent name identifies the main part of the molecule and tells how many carbons are in that part. Simply put, the parent name basically is based on the longest chain of carbon atoms that you can identify within the molecule, all right? The prefixes identify the different substituent groups or branches that are attached to the longest chain of carbon atoms in the molecule. And then the locants give the position of those attached branches or substituents, all right? And then lastly, the suffix identifies the primary functional group attached to the parent. Now, let me just say that when we talk about functional groups, which does not really apply when it comes to alkanes that we're going to talk about. Oh shoot, what did I do? Okay. Okay, what was I saying? Right, so this term functional group is basically a group of atoms within an organic molecule. In fact, let me write that definition down here. It's a group of atoms in an organic molecule that is responsible for the chemical properties of that molecule, or the chemical properties of the molecule, all right? And we'll talk about some of those functional groups later on, all right? But we won't talk about it with respect to alkanes because, strictly speaking, alkanes do not have any functional groups, all right? Okay, so these are the parts that will be involved in terms of naming a compound, all right? Now, so let me go through the rules, right? So these are the rules that we're going to use in order to name organic, naming alkanes, all right? So the first rule says you need to find the longest continuous chain of carbon atoms in the molecule and use that name of that chain as the parent name. The longest chain may not always be apparent from the manner of writing. You may have to turn corners in parentheses, all right? And then there's a sub-rule to that rule number one, which says if two different chains of equal lengths are present, choose the one with the larger number of branch points as a parent. Okay, so in order to explain this rule, I have to give maybe one or two examples. And I'm going to start with the simplest example of a molecule that I introduced earlier. So what I'm going to do is get out of this here. Whoops. And what shall I use? Can I use this? No, can't do that. Can I use this? What is going on here? In several. Let's see this work. Okay, let's look at this one right here. What can I? No, let me get out of this here. Let me just use Word. Okay, so I'm going to start with a very simple example. Now, we made this molecule before. It is CH3, CH, CH3, right? And if you recall, when I introduced this molecule, I also introduced this, CH3, CH2, CH2, CH3, and I introduced the term isomers. Remember that term? I said that isomers are different compounds having the same molecular formula, right? So these two compounds have the same molecular formula, but they're different because of how the atoms are connected to each other, right? In the case of this one, you have 4 carbons in one chain, right? So the name of this compound is simply butane, all right? Now in this case, you have 3 carbons in a chain, all right? And you have a methyl group attached to the middle carbon here, right? So basically, the identified longest chain is this right here. So the parent name for this particular structure is propane, all right? And then now, what we have to do is, let me just check if I've covered this in the rule already. Oh, I haven't done, okay. So, so what I've just described is basically covering what is stated in the first rule, right? We identify the longest continuous chain of carbon atoms in order to determine the parent name. In this case, there's a chain which contains 4 carbon atoms, so the parent name is butane. In this case, the longest chain contains 3 carbon atoms, so the name is, the parent name is propane, all right? So propane is not the full name of the compound, that's just part of the name of the compound. So let me just give another example. If you're given something like CH3, CH2, CH, and then CH3 here, and then CH3, right? In this case, the parent name, or the longest chain, I would say, has 4 carbons, right? So the parent name is butane, again, in this case. So that's the parent name, all right? Now, there are some cases, as the rule says, where the longest chain is not the most obvious one. So let me give an example of that. Let me erase this here. So you may be given something like this. CH3, CH2, CH2, CH with a CH3 here, and then down here you have CH2, CH3. All right, now in order for you to identify the parent name, you have to identify the longest chain. And you might be tempted, based on what we have done before, to say that the longest chain is this right here, right? But that is not true, right? So let me erase that and show you what the longest chain is. In this particular case, the longest chain is this right here, right? So in this particular case, you have a total of 6 carbon atoms in the longest chain, all right? So in this case, the parent name is hexane, all right? So the longest chain, the point of this is, the longest chain is not the most obvious one that you can see when it's written down, right? Sometimes you can go like this, go down, go up, whatever, but you need to identify the longest continuous chain of carbon atoms, regardless of how it's branching or twist and turn and all of that. So that's how you'd identify the longest chain in these examples, all right? Okay, any questions about what I've just covered so far in terms of determining the parent name? Any questions? Any questions out there in Zoom? Okay, so the next rule, let me go back to the PowerPoint here, says, beginning at the end nearer the first branch point, number each atom in the parent chain. And the purpose of that is to locate the different branches of the chain, right? And it says here, if there's a branching an equal distance away from both ends of the parent chain, begin numbering at the end nearer to the second branch point. Okay. So let me go back to the Word document that I had before to give a couple of examples. In fact, some of these examples would suffice. So what I'm gonna do now is erase the parent name so that I can show you how to do the counting of the carbon atom. So basically, according to this rule, what you're gonna do is identify, well, after you have identified the longest chain, right? Then you number the carbon atoms of the longest chain, starting with the end that is closest to the branch. Now, in this particular case, I'm going to use this example here. There are 6 carbons in the longest chain, which I identified earlier. This here, this CH3 group would be the branch, all right? That branch is bonded to this carbon. This carbon is closer to this end compared to its distance from this end, right? So therefore, the proper numbering system in this case is where you start with numbering this carbon here. 1, 2, 3, 4, 5, 6, right? And the reason for that, according to IUPAC, is that you want the carbon which is bonded to the branch here having the lowest assigned number possible, right? If you had started numbering from the other end, 1, 2, 3, 4, 5, 6, then this carbon here will end up with a higher number. You want this carbon to end up with a lower number, and you choose a numbering system such that this carbon, which is bonded to this group, has a lower number. So that's the reason why you start counting from this carbon here, and then you just continue. So let me just erase the second numbering system, which I had, because I don't want you guys to be confused. So this is the correct numbering system, as you can see right here, all right? So just to recap, you start counting from the end, which is closest to the carbon, which is bonded to the branch right here, right? So in this case, you start numbering from this carbon. Now in this case, based on what I've just described in the previous example, from which end would you start numbering in this particular case here? This is the longest chain we have identified, right? So would you start numbering from here, or would you start numbering from here? Remember, we start numbering from the end, which is closest to the carbon with the branch, right? So which end would you start numbering from? From the right or from the left of that chain? And you guys out there in Zoom, feel free to chip in with your answer. You can text it or you can just say it. Which end would you start numbering from? Which end is closest to this carbon? This carbon is what we're looking at. Exactly. So you start numbering from this carbon here. 1, 2, 3, 4. All right? And that's the proper numbering system. All right? Now things can become a bit complicated. For example, give me a minute here. Let me check the rule here. I don't want to jump the gun. Okay, okay, take it, it's okay for me to clear this, right? So let me delete this here, and I'm just gonna come up with an example. I'm just gonna make up something. Suppose you're given this example. CH3, CH3, and then you have CH2, CH2, CH3, and then you have CH3 here. All right, let's look at this example. So my question to you is, based on what we looked at in the previous 2 examples, from which end would you start counting from in this case? Because obviously the longest chain is this right here, which is the first thing we need to identify. We identify the longest chain. So my question to you is, okay, now that we have identified the longest chain, from which end would you start counting from in this particular case? Remember again, you start counting from the end which is closest to where the branches are. The branches are located on this carbon and this carbon. So in this case, from which end would you start counting from? Well?
The left.
Well, you could do it from the left. But guess what? It makes no difference. You could do it from the right as well. Right? The result will still be the same. So in a situation like this where there's a level of symmetry, then it doesn't matter if you start counting from the left or right, the result will still be the same. Okay. Now what I'm going to do is make a slight modification. Let me just erase these here and erase these numbers here. And let's say that I'm going to put this CH3 group here, all right? Okay, so again, the same question. Oh, and let me erase these stars that I put there. Okay. So this is the longest chain as usual. So now the question is, from which end would you start counting from in this particular case? Will you start counting from the left or the right?
The left.
Okay, and you're right. It is the left. And the reason why it is the left, 1, 2, 3, 4, 5, 6. The reason why I start counting from the left is because even though these two methyl groups, I'm sorry, I slipped up. I should have introduced that term here. These two CH3 groups are bonded to carbons that are equal distance from each end. The difference maker would be this CH3 group, right? This CH3 group is closer to this end, right? Closer to this end compared to this end. So therefore, that methyl group or CH3 group is what determines the direction that you're going to start counting from in order to assign the correct numbers to the carbons of the longest chain, all right? So the point being made here is that if you have two groups attached to carbons that are equidistant from each end, if there's a third group or fourth group, whatever, then you need to count the carbon atoms based on the location of that third group, all right, or fourth group or whatever, all right? So that's basically what rule number 2 is all about. Okay, let me go back to the PowerPoint here. So after assigning numbers, then, so basically we have done up to step number 3. So let me move on to step number 4. It says use hyphens to separate the different prefixes and use commas to separate numbers. If 2 or more substituents are present, cite them in alphabetical order. If 2 or more identical substituents are present in the parent chain, use one of the multiplier prefixes, di, tri, tetra, etc. And don't use these prefixes for alphabetizing. And full names of some of the examples we have been using are as follows. Okay, I don't have those examples there. All right, so it's a bit wordy. So let me try to explain what they're talking about here. Now, before I do that, there's one thing I probably should have introduced to you, which I'm going to do right now. Now, basically, I think it is okay for me to clear this, so let me delete that. Now, if you remember, I gave you a table last time, right? And in that table, I gave you the formulas of different alkanes. So, how am I going to do this? Alkane formula will be in that column, and the name of alkane, all right? This is not all the table that I've given you, but this is called methane, if you remember, and you need to remember these names, right? This is called methane. C2H6, oops, C2H6 is called ethane. C3H8 is called propane. C4H10 is called butane. C5H12 is called pentane. And then after that, it becomes easier to name these alkanes. So remember what the name of C6H14 is? Can somebody tell me? Feel free to look at your notes from last time. C6H14 is what? Hexane. C7H16 is heptane. Let me see here. Somebody, I think somebody is participating. Yes, Mr. Powers, I see you. Heptane. And then C8H18 is octane. And C9H20 is nonane. And scrolling down, C10H22, C10H22 is what? Decane, okay, and that's our limit at this level, even though we can go beyond that. Okay, now it turns out that if you look at the structure of certain alkanes, you can identify what we call alkyl groups, right? So these are groups that you can identify within a molecule. They don't exist outside of the molecule. They are part of the molecule, but you can identify them. And the structures and the names of these groups, these alkyl groups, is related to the structures and names of the corresponding alkanes. So for example, I'm just going to create another column here. Alkyl groups, all right? Oops, RUPS, all right? So in the case of the group formed by from methane, and by the way, to get the formula for the group, all you have to do is remove a hydrogen from the corresponding alkane. So for example, in the case of methane, the corresponding alkyl group will have this formula, CH3, right? So basically to get the alkyl group here, we remove a hydrogen from the formula here, and the name of that group, this is called, let me create another column here. The name of this group is called the methyl group. All right? So you'll notice how we get the name of the corresponding group. We replace the A and E ending with YL, right? So the A and E ending of the alkane is replaced with YL of the corresponding alkyl group, all right? So, in the case of the ethane, right, let me see if you can figure out what the formula for the ethyl group is. What will be the formula for the ethyl group? This is the formula for ethane, right? So how do you think we get the formula for the corresponding alkyl group, which is the ethyl group? What will be the formula? Remember how we got from here to here? We remove a hydrogen from this, and that gives you the methyl group. So how would you get the formula for the ethyl group? Starting with this, starting with the alkane, with the ethane.
Just remove the hydrogen.
You take one hydrogen off, so you're going to end up with C2H6, right? And this is called the ethyl group. All right? Another way of writing this would be CH3, CH2. All right? So that's the ethyl group. Yes, sir.
You said it would end up to be C2H6.
I'm sorry?
You said it would be C2H6 would be.
Oh, I'm sorry, C2H5, my bad.
Would there be a minus there as well?
Yeah, minus a hydrogen. Thank you. So this should be C2H5, my bad. Okay. So let's look at the alkyl group formed from propane. What would be the formula for that alkyl group?
C3H7.
C3H7. Now, let me just say that in the case of C3H7, there are two possible structures. In fact, let me write them down. Let me put it over here. Let me just draw a line here. One possible structure would be CH3, CH2, CH2. And the other possible structure would be CH3, CH, CH3. So in other words, these two groups are isomeric, all right? Now this group here, the name of this group would be N-propyl, and the name of this group would be isopropyl, all right? So those are the two possible groups as far as what can be derived from propane. Now, generally speaking, these are just called propyl groups. So I'm just going to put propyl here, but please be aware of the fact that as far as propyl is concerned, there are two types of propyl groups. You have N-propyl and you have isopropyl. N stands for normal, right? Which is basically a one chain, you know, where the hydrogen is lost from the end here, all right? Okay, now I won't go through the other groups, alkyl groups. Again, I'm only concerned with these at this level, right? So for those of you who have to do organic, believe me, you're going to get into all the other alkyl groups as well, but not at this level. Okay, now the reason why that's important is because when it comes to naming these compounds, in addition to identifying where these groups are located, you have to include the names of these groups in the name of the compound. So let me go back to the PowerPoint here. Basically it says you're going to use hyphens to separate the different prefixes and use commas to separate the numbers. If two or more different substituents are present, cite them in alphabetical order. That's where the naming comes in, right? And then it says if two or more identical substituents are present in a parent chain, then you're going to use the multiplier prefixes such as mono, well, ditri, and so on. You won't use mono. And don't use these prefixes in alphabetizing. Okay. So as I said before, this is kind of wordy. So the best way to learn this is to do a couple of examples. All right. Is it okay for me to clear this? Because I need a space to do some examples. All right, so let me lasso all this and start off. I'm going to move on. I'm going to start with the simple and then move on to the more complex. So let's say you're given CH3, CH, we met this before, and then CH3 here, right? So according to the rules, we need to identify the longest chain. Longest chain is this here, which means that the parent name is propane, all right? Then we need to number the carbon atoms of the longest chain. In this case, it doesn't matter which end we start from because it doesn't matter in terms of the location of the branch right here, right? So 1, 2, 3, all right? And then now we identify the branch. In this case, the branch is a methyl group, all right? And the methyl group is bonded to carbon number 2, okay? So the name of this compound would be 2-methyl propane. And by the way, the methyl propane should be one word, even though I have a space here, but it should be one word, right? So that's basically the name of that particular molecule, 2-methyl propane. So just to recap, so that you understand how we apply the rules to determine the name, we identify the longest chain first, 1, 2, 3, right? Then we look for the branches. In this case, the methyl group here, that branch is bonded to carbon number 2, right? So based on the parent name, based on the longest chain, the parent name is propane. Based on where the methyl group is bonded to, carbon number 2, we indicate that by putting 2-methyl propane, and that's how we determine the name of this compound, all right? Now, suppose I gave you this, CH3, CH, CH3, CH2, CH2, CH3, all right? So using the same rules, right? How would you come by the name of this compound? What's the first thing you would do? Based on what we did before, what's the first thing, the first step in this process? And again, you guys out there in Zoom, feel free to comment. Oh, actually somebody just commented. Okay, Mr. Powers just said, first you identify, I think what you're saying is, hold on, Was this an answer to the question I just asked? I think you're probably answering something different, Mr. Powers. I'm not sure. Oh, so you're answering, okay. So the first thing you have to do is identify the longest chain. Now you're saying, I think what you're saying is that based on the longest chain, the parent name would be heptane. And I would have to disagree with that, right? Oh, somebody else is saying something. Oh, you're saying it was an answer to when we were naming alkyl groups. Okay, I'm still not sure what you're referring to, but I take it you're not answering the question that I'm asking right now, right? Okay, so what's the first step, folks? Based on what we did before. What's the first step?
Identify the longest chain.
Identify the longest chain, which is the most obvious chain right here, okay? All right, then what?
Number them from the left.
Okay, so you start numbering from here. 1, 2, 3, 4, 5. Now there's something I would do before numbering, but you know, that's fine. I mean, if you want to number it first, that's fine. But there's something that I would do before numbering the carbon atoms of the longest chain. And that would be what? Remember how we got this here? In the case of this question, would identify the parent name.
Oh, yeah.
All right? So what would be the parent name in this case? Remember that chart I gave you, right? What would be the parent name in this case? Pentane. All right? Okay, and then I would number the carbon of the longest chain, which we did already. Okay, so after doing that, then what would you do? What would be the next step? Where the methyl group is, right? Determine the location or the location of the methyl group, right? And which carbon is the methyl group bonded to? What numbered carbon? 2, right? So what do you think the name of this compound is going to end up being? 2-methyl pentane. All right, very good. Okay, now what if I gave you this? What do you think the name of this compound is? What's the first step?
Identify the chain.
Okay, and how many carbons are on the chain? The longest chain, 5. So again, the parent name is pentane. Okay, so how would you number the carbon of the carbon atoms of the longest chain? Excuse me. It doesn't matter which end you start counting from. So 1, 2, 3, 4, 5, right? So what would be the name of this compound?
3-methyl pentane.
3-methyl pentane, all right? And that's how we name that. All right, very good. Now, supposing, whoops. Let me continue down here. Suppose you're given this, CH3, CH2, CH2, CH, and then CH3 here, and then CH3 here. Let me get rid of this stuff down here. Ignore this down here. Okay, so how would you number the carbon atoms in this particular molecule?
All right.
So 1, 2, 3, 4, 5, right? And so the parent name is going to be pentane. So what would be the full name of this compound?
2-methylpentane.
2-methylpentane. So guess what? This molecule is the same as the first one up here, right? They both have the same name. Pretty much you just turn the molecule around to get the other one, right? So, you know, that underscores the importance of following the rules so that you can identify the longest chain and where the other groups are located and so on. All right. So let me clear all of this here. I want to do a couple of more examples before we move on to the assignment question. So suppose you're given CH3, CH2, 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 CH, CH3, and then we have CH2, CH3, okay? Now, what I want you to tell me is how many carbons are in the longest chain in this particular structure?
6.
Huh? Sure about that?
5.
Huh? Remember, we have to pay attention to the fact that even though you might have some twists and turns, you need to identify the longest chain of carbon atoms regardless, all right? So how about you guys out there in Zoom? How many carbons are in the longest chain in this particular molecule? Exactly. You're exactly right. And let me show you where they are. See this? That's the longest chain in this molecule. All right? So the next step is we have to choose the correct numbering system. So from which end would you start numbering from in order to get the carbons assigned the correct numbers? Hmm? Yeah. So you start here. 1, 2, 3, 4, 5, 6, 7. All right? So the parent name is what?
3-methylpentane.
Oh, you jumped the gun. Okay, so you're right. 3-methylpentane. I was trying to go through the steps so that we can all follow. So the parent name is heptane because we identified 7 carbon atoms in the longest chain, and as she just said, the methyl group here is bonded to carbon number 3, so therefore the correct name of this molecule is 3-methylheptane. All right? Okay, any questions about this one? Any questions? Any questions? All right, let's do another example. Suppose you're given CH3, CH2, CH, CH3, CH, CH3, CH2, CH3. All right? Okay, so again, we go through the same steps, right? So the first step would be to identify the longest chain of carbon atoms. So how many carbon atoms are in the longest chain in this case? 6, right? So this is the longest chain, which is the most obvious possibility. So the parent name is hexane, all right? But you'll notice in this case, which is different from the other examples that we looked at, we have two branches, I'm sorry. We have this branch here and this branch here, all right? So the question now becomes, what would be the numbering system you would use so that we can have the carbon atoms correctly identified or numbered, right? And in this particular case, we try to number the carbon atoms such that the carbons with the branches have the lowest numbers possible. So if that's the case, from which end would you start numbering your carbon atoms in the longest chain in this case? Would you start from the left or would you start from the right?
They're both in the middle. Would it matter which
It doesn't
side?
matter, exactly, you're absolutely right. It doesn't matter if you start from here or start from here because these two methyl groups are basically equidistant from both ends, right? So I'm just gonna say 1, 2, 3, 4, 5, 6, all right? So the question now becomes, how do we include the fact that we have two methyl groups as branches from the longest chain in the name of the compound, right? Now, according to the rules, what we need to do is identify where those methyl groups are located and how many methyl groups are there. And this is the way we do that in this case. We put 3, 4, then we put dimethyl, dimethyl and hexane, and that would be the name of this compound, right? So please note, you have to indicate where the methyl groups are located. Very important, right? You have to indicate that in this case, the methyl groups are bonded to carbons numbers 3 and 4. And then you have to indicate how many methyl groups are there, and that's why we have dimethyl as a part of the name. So the full name of this compound is 3,4-dimethylhexane, all right? Okay, any questions about this one? Any questions? Any questions? Okay, let me clear this here. I want to do enough examples so that when you get to the assignments, questions, you should be able to handle it. So I'm trying to find different situations and possibilities as examples so that you can get a feel for how to tackle these problems. So let's say you're given CH3, CH, CH2. Oh, you have a question?
Will this stuff, will this stuff be on our upcoming test?
No, it will be in the final, but not on the test, no. I'll say more about the test shortly. CH3, CH2, CH, CH3 here, and then we have CH2, CH, CH2, CH3, okay. So let's say you're given that to name, all right? First step is to identify the longest chain. So let me see, how many carbon atoms are in the longest chain?
8.
1, 2, 3, 4, 5, 6. You said 8?
Yeah.
1, 2, 3, 4, 5, 6, 7. You're right, exactly, 8. Okay, so let me try to encircle it here. So it's all this here. So the parent name is what? If you have 8 carbon atoms in the longest chain, the parent name is?
Octane.
Octane. Then we need to correctly number the carbon atoms of the longest chain. So my question to you is, which end would you start numbering from? Would you start from this end or this end?
Yeah.
Hmm?
Leftmost.
Okay, so here, 1, and you're correct. 1, 2, 3, 4, 5, 6, 7, 8. All right? Okay, so we have one methyl group bonded to carbon number 3, and we have another methyl group bonded to carbon number 5. All right? So, what's the full name of this compound based on what we have just done?
3,
3, 5.
Dimethyl.
Dimethyl
Octane.
octane, exactly. All right, and that's how you do that. Okay, any questions about this one? Any questions? Okay, I think we have done enough examples, so now we can look at the assignment questions. By the way, did I give you guys a copy of this? Assignment number 9? Okay, let me give you that now. And I'm not sure if I published this for you guys out there in Zoom, so let me check and make sure that is done. Assignment number 9. Oh, I did publish it. All right, so let me download it. Okay, so let's look at these together. And let me see here. Based on what we have covered so far, we should be able to do all of number one. And number two. Number two is basically the reverse. You're given a name and you're asked to write down a formula, which is actually easier to do. At least we should be able to do part of number two. I'm going to stop at where we're not able to do, and then I'll explain some other things. Okay, so let me scroll down here. All right, so the first one should be easy, the easiest of these. Oh, let me see, somebody's saying something. Oh, I'm sorry, Mr. Powers, I keep responding to you way after the fact, so I just need to keep checking the chat so that I can answer you immediately. Okay, so let's see. The first question, what's the name of that particular alkane? Let me turn on the pen here. Okay, so what say you is the name of this molecule here? I think we did this one before, actually. 2-methylpropane. Yeah, we did do this one. So let me just write this down here. 2-methylpropane. All right. Okay. What about this one? Now, be very careful with this one, because remember, you have to identify the longest chain, right? So what do you think the name of this molecule is?
2-methylbutane.
2-methylbutane. You're absolutely right. And for those of you who don't get it, let me just explain. The longest chain would be this right here. Right? And you would start counting from this carbon. 1, 2, 3, 4. So the methyl group is bonded to carbon number 2. So that's why the name of this compound is 2-methylbutane. Okay, very good. What about the third one? What do you think the name of the third one is?
Orthoheptane.
You're partially right. What's the name of this group? You're correct about the 4, and you're correct about the heptane. And in this case, it doesn't matter which end you start counting from. So 1, 2, 3, 4, 5, 6, 7. But the key thing is, what's the name of that group? CH2, CH3.
Oh, ethyl.
Ethyl, exactly. So the name of this compound is 4-ethyl heptane. All right? Okay, what about the fourth one? Oh, I didn't cover an example of this. Okay, but anyway, we can still do it. So what's the name of this one right here? Well, let's go through the steps, because I think there's something I need to explain to you when it comes to naming this one. Let's go through the steps. So first step is identify the longest chain, which is, in this case, this right here, right? Okay, so what's the parent name?
Heptane.
Heptane, oops. Okay, so heptane. All right? Then what? What do we do next?
Count from the right.
Mm-hmm.
Not be counting from the right.
Count from the right. Okay, so 1, 2, 3, 4, 5, 6, 7. Now my question to you is, why do we count from the right and not the left? Because?
The branch is the closest.
Right, this branch here is closer to this end compared to this branch to this end right here. Okay, so this is the correct numbering system. Now here's where I have not done an example of this previously. So let me explain what happens here. Of course, we identify this as the ethyl group and this as a methyl group. And IUPAC has said that when it comes to ordering these groups in the name of the molecule, it must be done in alphabetical order, right? So in other words, the name of ethyl must come before methyl, right? So when we put this together, the name of this compound would be 3-ethyl dash 4 dash methyl heptane, and that would be the name of that molecule. So when you're how should I put this? When you're putting the names of the alkyl groups within the name of the compound, it must be done in alphabetical order. All right? So 3-ethyl and then 4-methyl heptane would be the answer for this, the name of this molecule. All right? Any questions about that? Any questions? Any questions? Any questions? All right. I take it it's okay for me to clear this, so let me do that now. And let me scroll down. Okay, let's look at this one. Now, in this case, we go through the steps like before. So the first step is to identify the longest chain, which would have 1, 2, 3, 4, 5, 6, 7, 8, right? So the parent name would be what?
Octane.
Octane, okay? And this is another one that I haven't, another example which I haven't showed you. So I need to explain this. Okay, so once we identify the longest chain, the question now becomes, well, let's identify the branches first. So we have one branch here. What is that called?
Methyl.
Methyl. And what's the name of this branch? Propyl, all right? Now, the question is, actually you should be able to do this one, actually. Where do we start numbering from?
Left.
From the left. So 1, 2, 3, 4, 5, 6, 7, 8, all right? So what do you think the name of this compound is? Now remember, the substituents must be placed in the names, I should say, of the substituents or the branches must be placed in an alphabetical order in the name, right? So what do you think, which one would you indicate first?
3-methyl.
3-methyl
Dash.
dash.
Dash propyl. Or -5 dash propyl.
Exactly, -5 dash propyl. And that would be the name of this particular molecule. All right? Okay, any questions about this? Any questions? Any questions? Okay, can I clear this? Can I clear this? All right, let me do that. And let me scroll down. Okay. Let's see what you come up with for the next one. Let me hear what you have to say. What's the parent name?
Heptane.
Heptane, all right? Okay, now the next question is, from which end would you start counting from?
The left.
From the left. 1, 2, 3, 4, 5, 6. And the reason why I do that is because, I'm sorry, wrong numbering system. Whoops, I skipped the carbon. This should be 3, 4, 5, 6, 7, right? And the reason why that you start counting from this end is because this carbon with the 2 branches is closer to this end compared to this carbon with 1 branch, right? So the numbering system, this carbon will take precedence, so you start numbering from that end, from the left side. Okay, so What would be the full name of this compound? Now remember, because you have two methyl groups, you have to identify that not only, actually, you have three methyl groups, right? You have to identify where they're located and how many, right? So what do you think would be the full name of this compound? This molecule?
3,5 trimethyl.
Okay, you're partially right. In fact, you're just missing one thing. Can anybody guess? He said 3,5 trimethyl heptane. That's what you're saying, right?
Yeah.
There's one minor thing that you're, well, relatively minor thing that you're missing. Can anybody tell me what that is? Anybody over there in Zoom? Can you tell me what that missing thing is? Mr. Spivey said 3,5 trimethyl heptane. And that is, if that were like a 2-point question, you'll get 1.5 out of 2. Anybody can tell me what the one minor missing item is? Okay, let me help you guys out. 3, 3, 5. Right, you have to indicate where each methyl group is. So you have two methyl groups bonded to carbon number 3, you have one methyl group bonded to carbon number 5, then trimethyl to indicate the number of methyl groups, heptane. And that's how you name that. 3, 3, 5, trimethyl heptane. All right? Any questions about that one? Any questions? Any questions? Okay, what about the next one? Next one is too easy. What's the name of the next one? Where would you start counting from? 1, 2, 3, 4. And the parent name is what?
Butane.
Butane. Okay, so what's the name of this compound?
Two comma 2
2,2
dimethyl.
dimethyl butane, correct. All right? Any questions about that one? All right, okay, so let me clear this, scroll down to the next page. Oh, this one is too easy. What's the name of this one? You should be able to do this without me going through the steps.
Two dimethyl propane.
2,2 dimethyl. What did you say, propane?
Yes.
And that is indeed correct. Okay. What about the next one? And you guys are getting some good practice here for organic chemistry, if you have to do organic chemistry. I'm quite sure your instructor at that point will be impressed with your knowledge. Okay, so what's the, well, let's go through the steps. How many carbons are in the longest chain in this one right here?
5.
5, so the parent name is pentane. Oh, somebody said something here, hold on a minute. Oh, Mr. Powers have jumped the gun, okay. Let me just go through the steps, but you got the right answer, Mr. Powers. Parent name is pentane. And then, what's the next step? The numbering system. In this case, it doesn't matter which direction you start counting, right? You could have done 1, 2, 3, 4, 5, or you could have, there's several actually directions you can take this, would make a difference. You could have done 1, 2, 3, 4, 5 like this, or 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. There are many ways, right? It doesn't make a difference. So I'm just going to stick to the numbering system I have here. Okay, so what's the next step? What's the next step? Now that we have identified the parent name and the numbering system, the next step is what?
We identify what
We
the
identify the branches, right?
branches.
We have those two branches, right? What are the names of those branches?
There's two Ethels, so it would be.
Right, there are two ethers, so it'll be what?
3,3 diethyl.
3,3, you're correct, 3,3 diethyl pentane, which I think is what Mr. Let me check and make sure. I think that's what Mr. Yes, what Mr. Powers said. All right. Okay, so I'm gonna stop here for today. So what I want you guys to do is try the others. Oops, hold on 1 minute. So try the others up to, hold on. There. Up to, let me see here. Up to question number 2. And unfortunately, I did not number these or letter them. So I'm just going to point to where you should stop. Okay, so basically you should stop where you get to 2-ethyl-2-methylheptane, right? I'm going to explain how to name these next time we meet, right? So up to where it says 2-ethyl-2-methylheptane, that's where you're going to attempt. You should be able to do those, right? All those up to that point. If you have any problems with any of these, again, feel free to give me a call and I'll help you out, all right? But I'm kind of confident that you guys will be able to do those based on what we have covered today, all right? Okay, let me just say this, and I'm going to post an announcement in Canvas concerning test number 3. So what I'm going to do is I'm going to give test number 3 on the week of on the 30th, which is week after next, all right? I think I've sent you guys back this morning your graded assignment number. Which one did I send back to you guys? Okay, let me check. Sent. Assignment number 7, right? I sent you guys back. No, wait a minute. I'm confusing you guys with Chem 1. I don't remember which ones I sent to you. Hold on. I should be able to find those. If I go directly here. I sent some this morning, but that was for my Chem 1. Okay. I think the last one I sent was assignment 4. So I have some assignments that I need to grade and then send to you ASAP. But let me just tell you what your test will cover. Your test will cover chapters 5, 6, and 7. Now 5, I sent you a message, I think, where you have to add some more stuff, ice tables and so on. And so I haven't checked those yet. I'm not even sure if I'll be able to check it today, but I'll check it and print them and grade them. And assignment number 7 is electrochemistry, which I think you guys have submitted already, so I have to look up that as well. And then assignment number 8, you won't be tested on, which is nuclear chemistry. So that one is not as urgent. So I'll be grading, I've already graded assignment number 6, so you should have those sent to you. And 5 and 7, I have to hurry up and grade those so that you have them to review. I should have them done before this week is out so that you can review it for your test number 3, all right? So I'm just going to post that, what I just said, I'm just going to post that in the form of an announcement. And also, I'm going to look up the date for the final exam, and I'm going to post that in the announcement as well, all right? So look out for that, look out for those 2 items, all right? Okay, so that's it, folks. I'll see you guys on Monday.
It's the 30th, right?
Yeah, week after next.
All right.
Yeah.
See you in lab.
Yes, sir. Let me do.